Boom. Painless.
Getting better at this podcast thing.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 245. This week we'll be talking about the Silver Swan, ET's umbrella antenna, and model tanks versus space shuttle tires. In Hackaday news, we got the winners for the Halloween Hackfest out. Tom wrote it up, actually, this year's spooky winners. You should check it out. Some of them are really fantastic.
Yeah, I think this is a contest that really resonates with our people. I think I said in the write-up, this is probably the most hacker-friendly holiday out there, right? We have precious few opportunities to build crazy contraptions and harass the neighbors with them. So they usually come out of the woodwork with some really cool stuff. The top winner for this one, like the flying ghost, was such a cool idea.
So awesome.
You know, we've seen people do like, a multi-copter thing with a bed sheet hanging under it, and that's pretty cool, right? Like, especially at night. But it sounds like angry bees, right? So you kind of know, wait a minute, there's propellers at work. I know that sound. But for this one, Scott Duckworth, he set up this like cable system between the houses in a cul-de-sac, so it would move over the street, but without any obvious form of propulsion. It's just like the bummer was night of course, there was a bug in the code, and the flying ghost just did more hovering than flying. And then the next day, in the light of day, figured it out. But hey, ready for 2024 now.
That's like the most Hackaday Halloween story I've ever heard. Like, he gets it finished up on the day after. But but it's so rad. And if you are over on the website, you've got to watch that video because it's really pretty darn scary looking. Looks pretty sweet.
If it was nighttime and I was 10 years old, I am not leaving the house. I'm going back in. Just bring me the candy later.
You really can't figure out how it works at all if you don't know that it's on, with a three-way winch system. Yeah.
And very understanding neighbors around there too. Like,
right?
If I went to my neighbor and like, listen, I want to go on your roof and I'm going to install a device.
The deal. Yeah. Did he say how he coordinates the three? I mean, they're on people's roofs. It's got to be Wi-Fi or something, right?
It's NRF 24 modules talking to each other, and then there's an ESP32 like hub that does the math, it sounds like.
And it's got these like three separate kind of identical looking winch modules that he just deploys in each place, and boom, he's done.
Super heavy duty looking winches. I don't actually remember if it said were he able to find these somewhere? Are they made? I mean, if he made those winches, those are some pretty serious pieces of equipment.
They're definitely heavy steppers. It looks like a whole bunch of 3D printed gears and stuff in the winch box. So my guess is that's custom made.
Wow, that's even wilder.
Pretty rad. Other hacks include an actual fire breathing dragon.
Yeah.
The haunted keyboard. I think we might have even talked about this on the podcast before, but it's got AI inside it. So you type to it and it responds with spooky messages. The one in the image going with the article is fantastic. Someone types in, "Are you in my keyboard?" And it types back, "I lurk within the shadows, not within mere machines." That's pretty rad.
Yeah, it's one that you really should watch. It's hard to kind of get at first, It's like, okay, what does that mean, a haunted keyboard? But it really is. You can imagine there being a little screen set up, and you have visitors come over, and just it's really like a futuristic Ouija board kind of thing where you enter in your questions and you get these vague, spooky responses.
Yeah, exactly. That's super. Ton of the honorable mentions were good too. I mean, it's always like this. The candy pult, I think that was Christina's favorite. It's got a little spring-loaded catapult thing. You put the candy in there and it goes thunk and it hits a chute and then it slides down. I think that's pretty sweet.
I thought that was cool too, because it's super low tech. I mean, some of these things, like the bar is high, right? A cable flying ghost with winches are out throughout the neighborhood. Like, not everybody can pull that off, but this is something that you could definitely. I mean, it's cardboard and rubber bands and stuff, and it still has a really cool feel for, especially when kids are coming up and a lot of activity going on for them, and makes it feel a little more special than just grabbing a handful out of the bucket.
A great action for not much work, I think. Although maybe I underestimate how much work it was. And yeah, I love the way you close the article. Only 11 months to go.
Yeah, get working.
if you procrastinated and your Halloween project, you got it done, but you didn't get it documented, that's cool. You're 51 weeks ahead.
Yeah, don't think of it as being late. Think of it as being very, very early to the next one.
This year, Halloween at our house got turned into me doing last minute work for SuperCon. So, A, it paid off, but B, Halloween suffered. And as our resident American on our block here, Germany, I have failed you. But next year, I swear, I will come back in strength. And we've already talked about your awesome proton pack. So, no more time in the sun for you.
That's fine.
You burnt your 15 minutes of fame.
And I did the same thing too. I that's a year old, and I just didn't have time to write it up. And I could have, wrote it up in November, but I was like, nah, let me wait. Let me wait until next year, and then I'll write it up. Somebody actually, I did like a little YouTube video to show the lights, and somebody in the comments were like, "How did you achieve that dusty look?" And I didn't want to say, "Well, it sat on a shelf for a year."
As actual dust. That's commitment to get actual dust on your model, man. You put it off for a whole year. Just to
if you want to
dust.
get that neglected and sit on a shelf look, why don't you neglect it and put it on a shelf? Some people are aging cheese or wine, and I'm aging my hacks.
Well, with that, we have to head on over to What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
Let's see what we got in store for you this week. Last week was a Guess the Sound week. This week is a Torture Tom with the Sound week.
I did listen to it last week, but let me listen to it with my headphones. Maybe
Yep.
I'll get some more here. I mean, my first thought is some kind of spring shears or something.
Yeah.
I remember you saying from last week that it was kind of a common thing. I think you even had one, right, in the room with you. So something.
I don't know if it's common. It's common for a certain subset of people.
For the people who might be listening to the production. Yeah, I don't know. I mean, it's too springy to be like vice grips.
Right? Good.
Is it like an automatic wire stripper?
Boom.
There we go. Wow.
Hot diggity.
Wow.
Yeah, dude.
That's the first one in a while.
Yeah, dude. Sometimes you just need to let it marinate for a little bit and it percolates up to, yeah, not bad.
Yeah. Oh, I think pretty common, like you said, in this audience at least, right?
Yeah, exactly.
And these like the little duckbill style ones.
This was a contribution from Chris Lott, and he actually sent me a video of him using them. So maybe I'll scrounge up the video and we can post it on the website. Go over to watch the actual video with the actual strippers in question.
Wire strippers in question.
Wire strippers.
Yeah.
Oh, man.
Don't get too excited.
I guess you could call them like Candy and Diamond or some other stripper names.
Ooh. Yeah, the second most common answer was all sorts of ratcheting crimpers. And no, those sound like this. I just got a new pair of ratcheting crimpers today. I'm totally stoked to use them. They're the little JST XH ones, which are tiny.
Crimper did. That had kind of flashed through my mind too, but it definitely had that it's like a shear, like a cutting sound. And
I was looking for my pair, and actually, I think they're downstairs. I think my wife and son have stolen them from me. I lied to you. They are not in this room, but they are downstairs in the living room. That's even stranger.
That's another level of nerddom. Like, where do you keep your automatic wire strippers? Right here in the living room.
We have 35 people answered. 15 of the answers are correct. So congratulations to everybody. That was actually really good. Like I said, crimper was the number 2. Couple staplers. Man, I'm going to have to put a stapler on sometime. The number of times we get stapler as an answer. I'm going to actually someday have to get a stapler in there.
And no one will get stapler then.
No one will get stapler. That's right.
They'll be like, that's the automatic wire stripper.
I'm going to cheat and use one of my canned random number generators. I'm using... let's take the hash of a file on my hard drive. How about an image I used up on Hackaday recently? This is hashing the banner image for Halloween Hackfest and taking the result modulo number of contestants who won, which is 15, and the random, I guess completely deterministic but unknown to me value is 8. That's not a random number at all.
It's random as long as you don't get it again.
It's random as long as I don't use that same file again.
Yeah.
Yeah, this is a deeper philosophical question about what is randomness, I think.
It's funny. I think there's like a Dilbert cartoon where they get a random number and it keeps coming up 8, and he's like, how can 8 keep being the same random number? And it's like, well, there's a chance it could be something different, but
This is congratulations to Adrian, automatic wire stripper. Short, to the point, and correct. I'll be getting in touch with you, get you a Hagaday podcast t-shirt. Everybody else out there, stay tuned for next week. All right, well, my first hack this week is a video about the restoration of the Silver Swan automaton. This is a kind of a 7-minute documentary video by the Bose Museum. It's horrible, like AI narration. Don't ever do that out there, kids. But other than that, it's fantastic documentation about taking apart this beautiful 250-year-old automaton, the Silver Swan, cleaning it up, putting it back together, and getting it running. I think one of the things that's striking about this is how good a lot of the metal work is. And this has nothing to do with any of the automatoniness of it, but just like how amazingly feather-like and leaf-like the silver metal work is. It's just, that really seals the deal. But then there's a whole bunch of other things that are kind of more mechanical and interesting about it, including it's floating on what's supposed to be a river, and it's made up of these like twisted, spirally, square glass rods that then turn, and it makes a fantastic, almost wave / river flow like effect. That's so cool. It's got a bunch of little automaton fish that swim back and forth. But the real story, of course, is the big swan in the middle. How the inside of its neck works is glossed over quickly in the video. It's driven by kind of what look like super thin bike chains, basically. It's got a really neat movement to it, and I think that part's pretty cool. I wish they spent more time with the video camera on the clockwork on this thing. What seems to sequence everything is one of those discs with a bunch of pins in it, like you have in music boxes, like those little ding 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 music boxes, except they're pushing a bunch of arms and making everything move. But there are so many of them that it has to be, it's an incredibly intricate, multi-dimensional movement at the same time. Really just fun to watch. The video makes me wish we could see more of it, but you should absolutely check it out anyway.
I guess that's the downside of it being like a museum piece for, shall we say, normal people.
Yeah.
I wanted to see a lot more of the technical aspect of it, but I could see how that would be very boring for, the school child that's probably meant to be coming to see this thing in the museum. I was really cool to see this come up because I think a lot of people have probably seen this in video, the Silver Swan. I mean, I know
really?
I've seen it. It's got a couple of them, like, Ripley's Believe It or Not shows and stuff where it's like,
Okay.
yeah, you thought robots were a modern thing. Well, here's blah, blah, blah.
Right.
So I had seen it a bunch of times in different kind of media, and I actually didn't know like where it was, and kind of what ended up with it. So it is.
Oh, right.
It's cool to see that it is, being protected and restored, and I think that, they're actually raising money now is kind of what the gist of the thing was too, right? Like they're actively doing a restoration thing and they're trying to get funds together. It is wild, the stuff we take for granted, right? Like you said, it has kind of like a music box sort of internals because that was like state of the art stuff at the time, right? That would have been the microcontroller of the day.
Yeah.
So looking back at how they solved these kind of problems and what they were able to accomplish is pretty incredible and humbling too. Like, you think we got it hard? We just got to copy and paste some code from GitHub, but this was like literally, there's a reason people are still talking about it hundreds of years later, right?
Of course, then all the other neat videos of automata pop up in your YouTube stream, and so then you waste your time watching the rest of those. And I mean, if you're me. And a bunch of people pointed out, other cool automata in the links, which is fun. Fran Blanche did this marvelous video on the, what is it, Maillardet automaton from before, and that's really cool looking too. So, yep, makes you want to build one.
I should say too, if you go on the museum's website, they have like a 3D virtual tour of their automaton. So if you can't get there in person, it's kind of cool. You can use the arrow keys and walk around and check out the exhibits. So that's pretty cool time waster. In addition to the YouTube rabbit hole you'll be on. Well, this one technically comes from last week, but I couldn't not talk about this one. This is from Save It for Parts. Umbrella antenna protects you from rain, but not the way you think. I don't know about anybody else, but when I saw ET, the part that stood out to me the most is his communicator that he makes to phone home, right? I think a lot of hackers of young and old probably were mesmerized by that scene, the speak and spell and all the stuff that was hacked together. And kind of the centerpiece was an umbrella upturned and lined with aluminum foil. And, when I saw this as a young, impressionable nerd, I said, well, that's all you need to contact deep space is an umbrella and enough Reynolds wrap to, get you in trouble with your parents. As I got older, I realized, oh, that's ridiculous. That wouldn't work because maths and things like that. But Save It for Parts, it must have been sticking in his mind for the last 40 years because he did exactly that. He took a regular umbrella and he lined it with aluminum foil, and he wanted to see if he could pick up NOAA weather satellites. And the first attempt, it's the real MacGyver version. Not only do you have the umbrella with aluminum foil, but even the the feed is a pie tin and some hand bent wires, RTL SDR hooked up to a phone, and pretty incredibly, even that sort of worked. I mean, it worked enough that you could see something was happening, right? But it wasn't enough, not an ideal reception. But undeterred, he comes back, and he this time with a tripod mount for the umbrella and now a proper commercial feed, and he was actually able to get a really decent full disc image from the NOAA satellites with this thing. So it was super impressive to me that this this idea that they probably did in the movie just as like a joke, like, oh, this looks like a satellite dish, right? But it does work in a pinch. Obviously, Save It for Parts, we've written up a lot of his stuff. He has a really impressive collection of satellite dishes. Only people in this community, right, would have a collection of satellite dishes. But
right.
If you ever look at his video, he really, really does. There's a garage full of satellite dishes. Among his stable, this is certainly the most poorly performing. So I don't think he'll be using it for too many future experiments when he has, proper military foldable SATCOM dishes. But it was a really cool example of, what you could do on a budget and, pretty quickly. There's a large number of people listening to this right now that have RTL SDRs probably sitting in a drawer, and there's a good chance you got an umbrella and tinfoil. So, maybe this is not an ideal setup, but it kind of makes something that previously would have been completely impossible, or at the very least, very impractical for the home gamer to do, is now more possible than perhaps you ever realized.
This reminds me a little bit of the old days of Wi-Fi boosting with all sorts of sketchy home-built antennas, right? And there were people using those, those fold out vegetable steamer strainers, or they were using colanders, or they were, there was the whole thing with the Pringles can. There was the whole thing with even just 3 planes together to make a corner reflector, and you put your antenna in the middle of that, you get a little bit more gain. I mean, none of this stuff has to be necessarily over-engineered unless you really need that last decibel of directivity or whatever. A lot of it'll work, if you just get it kind of close enough. And I think there's a lot of space there for messing around, and that's why I like to see this too, right? This is the colander antenna, except
scaled
slightly bigger, right? And he makes it work, so that's just lovely. And it also reminded me of a couple weeks ago we ran an article on an inflatable antenna. Need a low mass antenna in space, just blow it up. It's basically a balloon that's half covered in mylar on one side of it, and you put the feed in the middle where put the feed in the approximate focus, And it's good enough, but it doesn't weigh anything, right? Because it's basically on a balloon and it's full of air. So the antenna, the dish itself doesn't weigh much at all. So I think these kind of approximate solutions are worth having in mind for those times when you don't need every last little bit of sensitivity or whatever. And I think that's really cool to see it work.
I kind of thought like the focal point of the dish would be farther away. I almost thought you'd have to extend the handle. Just I don't know, just kind of eyeballing it. But in fact, he's got the feed like halfway down the handle. It's way closer to the surface of the quote unquote dish than I would have assumed. So that's kind of interesting. But you could just kind of experiment with it, right? You're gonna have, I imagine, different angles and handle lengths depending on who your umbrella manufacturer is. So you might have to slide the feed up and down the handle to get the sweet spot. If that's the worst thing you gotta do, it's not like you have to extend it or put it offset or something. And I also thought it was cool that he's got the RTL SDR hooked up to an Android phone in this, and the state of SDR tools on Android has gotten to the point where he's actually able to do it all around his phone, so that kind of lends to this expedient bushcraft kind of thing where he starts the video saying, oh, what if you're out by yourself and you need to get a weather report and you don't have internet signal, is it possible to pull it down from a satellite? And yeah, actually it is. It was pretty cool that you could get like the full disc image of the Earth right on an Android phone without having to have a laptop or anything. So that's maybe something, even if you just take away that, the state of the art in mobile SDR software is pretty impressive right now.
Oh man, and before we leave, I have to throw another one in there. If you want to go the exact opposite extreme and you want to worry about getting your dish parabolic down to every millimeter, you read this write-up of some work by Joe Martin, Tune Your Dish Antenna Like a Pro. In this one, he's compensating for like the sag of the metal in the antenna. Like it's he's built a 2 degree of freedom gimbal mechanism that he can put in the feed horn, and it can actually map out the antenna completely. And he ends up pounding on it a little bit here and a little bit there, kind of ironically making it not quite parabolic, but exactly not quite parabolic so that it counteracts gravity's effect on it. So when it bends under its own weight, it bends it back into perfect shape. In case the umbrella covered with aluminum foil isn't good enough for you, this is like the exact other extreme where he's worried about, half a millimeter's deviation out of perfect parabolicity.
The ET umbrella is just the gateway drug to a serious antenna habit.
Well, this next hack is a simple circuit. In fact, the write-up's title is Simple CMOS Circuit Allows Power and Data Over Twisted Pair Wiring. And I picked this one up because I thought it was really clever. This is 0033MER. Can you read that? No, I can't read that in lead speak. 0033MER. It's an electronic watchdog circuit, essentially. On one side, he's got a sensor that he wants to, in this case, say whether it's freezing in his garage. So he's got a little microcontroller-driven temperature sensor. And on the other side, he's got an annunciator that says, oh, hey, it's freezing in your garage, in between kind of 100 feet of twisted pair wiring. He wants to put power and signal over this and does it in a particularly clever way. And that is that the microcontroller basically is always getting powered over these two wires, so using them as positive and negative. But then it has a diode and a big enough capacitor on it that it can short the line together, essentially cutting off its own power supply for about a millisecond or so, but also sending this signal to the downstream receiver device. And the downstream receiver is as simple as it could possibly be. It's a monostable multi-vibrator. And that means that every time it receives the signal, it stays on for a second. And the gimmick here is that the microcontroller sends the signal twice a second. So if it's always updating, if it's always pinging the receiver is always on. It's only when it fails for more than a second to ping the receiver that the receiver then says, hey, there's an alarm condition, it's freezing in the garage. Now, this is a really cool setup for all sorts of kind of high reliability on-off, is it doing something kind of setups, because A, it gives you power on the other side with just the one pair of wires. B, if something goes wrong on the other side, it's fail safe because receiving the ping is what prevents the kind of watchdog receiver side from sending the alarm. So if the wires get cut, if they wiggle loose, if the microcontroller breaks, if anything goes wrong that prevents it from sending its periodic little blip, you will get the alarm condition and you'll get notified that you have a problem. And last, of course, this is like pennies in parts. It's a simple, I think you could actually literally do it with a 555. He's using a CD 4538, but I really think you could do this with a 555. Like that's kind of one of its canonical uses. It's a really cool system and just a very simple, basic, foolproof, obvious mechanism that really could be useful in a whole bunch of circumstances. And, the receiving side is dead simple, but the sensor side can be any microcontroller you can power over these wires.
That's why I really like this one. This could be useful in a wide array of applications. And, as much as I like seeing, finished projects, right? Those are kind of our bread and butter at Hackaday. I do like to see these simple, building block kind of things where here's something that'd be cool and you could use it for all sort of things, just something to file away mentally. I know when I look at a project, I kind of maybe deconstruct it a little bit in my head and I say, oh, that's a cool idea, that that's an interesting library, or that's a part to keep an eye on. But the ones like this kind of already do it for you, right? Where it's just here's one part of a larger thing, and here it's well explained, and do with it what you will. So we're kind of jaded these days. We have cheap ESPs and stuff, and there's certainly a tendency to just Wi-Fi all the things, but that has a lot of overhead and complication and is unnecessary, right? And a lot of times, if you just want a simple kind of thing, you don't really need to have Wi-Fi and a whole TCP IP stack just to tell you it's cold outside. Like you don't need to be so complicated. So it's cool to see like these, dare I say, almost like a bare metal kind of solution to something that I think a lot of people would reach for a much higher tech answer these days, but it's not always necessary and even appropriate, to go for the super high tech version when there's, like you said, something you could do with 555 and some wires and just some kind of basic electronics theory.
When you say Wi-Fi, it makes me think of all of the different failure modes, right? It doesn't provide power, first of all. If you do Wi-Fi, you've got this huge power budget all of a sudden that you have to worry about. And like even if you do something lightweight like BLE or any of these other protocols, it's still a bunch of power to push that across. And this one's the opposite, right? Like this is carrying the power over the wire. So like if you can get a pair of wires out to the thing, this is your solution. And I do kind of like that. There's definitely a convenience factor to being able to do it wireless.
Oh, yeah.
But there's also an inconvenience factor, which is you got to figure out how to power the damn thing. This solves that problem and the data at the same time. And it alerts you to the condition you want to look at all in one device. And that's just, it's literally fail safe. It's delicious. Love that.
All right, for this next one, I cheated a little bit because I wrote this one up, but I really enjoyed it, so I wanted to talk about it again. This is that time NASA built a tiny tank to pop shuttle tires. The space shuttle is, big surprise, it took a lot of R&D and a lot of different things to make a giant space plane work, and even kind of work. There was few stones left unturned, right? And that goes all the way to the tires. When the shuttle touches down, it was going way faster than I think any flying object, and certainly had ridiculous amount of mass. So the tires had to be ridiculously robust, like much more than anything that was available on the market. So NASA had I think it was Michelin, or they made a deal with one of the tire companies to make this crazy tire that could be inflated to almost like 400 psi of nitrogen and 20 ply and all this crazy stuff, right? Something like $30,000 a tire, but a drop in the bucket when you're going to space on NASA's budget. In the 90s, they were doing some upgrades and they were kind of revisiting the tires and the landing gear, and they were sort of like trying to test them to destruction, right? How much could these tires take, and when do they go boom? So they outfitted a commercial aviation plane with like a secondary landing gear set, and they'd basically land this plane, and when the plane would land, they would just force this tire into the ground and like drag it on the tarmac and just beat the hell out of it. That's a NASA technical term, and just see like what kind of abuse, how hot does it get, how much the rubber wear off, and all this stuff. It was a sort of test of destruction thing. We want to see these things blow up. But the trick was, if they didn't blow up, you now have what is basically a small bomb on the tarmac. And there was this concern, like you can't send somebody out there. NASA estimates in their write-up that it has like 2.5 sticks of dynamite in there in terms of like explosive force if this thing was to let go. So this is a very dangerous situation. And originally they were going to use actual like bomb diffusing bots, like the military would have, but they're expensive and big, and they weren't really designed for this kind of thing. So one of the contractors at NASA was like, well, I got an idea. And he bought a remote-controlled Tiger tank from World War II, kept the bottom hull, kept the treads, kept the complicated bits of making a tank, right? And on top of that, made a new metal deck and strapped like an off-the-shelf DeWalt drill motor with a big drill bit in it, and set up a remote video thing, and drove this tank out there and drilled holes in the tires to let the pressure off. Hopefully not non-explosively. My understanding is that the little tank did survive. It diffused many tires in this test program and survived. It exists today it's in some the Armstrong Flight Research Center has it now. This is like real life hacking stuff together, and you got to think, for the guy who made this, what a pleasure. Where you're working for NASA and they're developing what's arguably the most complex machine ever to fly. How are we gonna test it? What are we gonna do? There's explosive tires. We got to come up with some high tech thing, and you're like, no. I'm gonna go to the hobby store, and then I'm gonna hit the Home Depot, and I'm gonna make this little tank, and I'm just gonna drive it out there, and we're gonna poke holes in it. It's kind of a solution I feel like a lot of the Hackaday readers would come up with. The moral of the story, though, is like the original bomb robot from the military or whatever was like a 6-figure thing. And that was even in the 90s. And they were able to build this for, a couple grand, which seems high now. But you also got to remember back then, stuff like, first person flying drones did not exist, right? So you couldn't get like this cheap video hardware and like a headset. So a lot of that stuff had to come kind of a premium. I think the tank model itself was a few $100. So, it adds up when you're building your little tanks. But no, it's just a really cool story. And, when it came by, I kind of jumped at the chance to write up, a little known story of one of many little known stories that it took to build the space shuttle.
All right, well, from one dirty hack to another, keeping a Mazda's radio on after the engine shuts off by SSH16. This is a problem that a lot of us have. If you are sitting there, you're listening to a radio show, you want to keep working on it, or, you're talking on your phone and you want to keep the speakerphone in your car running, but you got to turn it off because you're parked. So you hit the off button and boom, there's the end of your call. What can you do? In his car, it's got one of those push to start, push to stop buttons, and that means that there's a start-stop module deep inside the car. And this actually activates the power on relay, the ACC relay. And his first suggestion is that you could just go in there and snip the yellow wire that goes between the power on, power off, and the ACC relay. But then you'd have to rewire that all yourself. And I don't know, something about cutting the wires in my car makes me unhappy. Instead, he comes up with this alternative solution, which is building a little microcontroller board that will keep this ACC relay powered on, but then listens to the car's CAN bus to hear when he opens the car door, and then it turns the radio off. So this means he can, leaving everything stock, plug his little device into a 24-pin port there that conveniently has access to both the ACC relay's power supply and the car's CAN bus. He plugs this in and it's done. That's the solution. Keeps the power on after you've pressed the power button, but until you open the car door. Problem solved.
It's always cool to see these kind of automotive hacks. I don't think I'm brave enough to cutting the wires on a thing you need to get to the grocery store every day is not my idea of a lot of fun. And there is some cool stuff like with the CAN bus. I don't know how likely you are to cook your car messing with that stuff, but yeah, I will definitely live vicariously through these other people modifying their very expensive and complicated automobiles for my viewing pleasure.
There is damage you can do with the CAN bus. There are like ECU reprogramming commands and stuff like that. But as long as you're not issuing those,
Yeah.
especially if you're just listening, you can listen all you want on the CAN bus and do absolutely nothing to the car. So that's kind of costless. There's a lot of data going across. And that's the other thing about OBD versus CAN is these Wi-Fi OBD. I do that every time. The wireless ones are, like $10 and they're dirt cheap, but they just don't have the throughput to cover all of the crazy messages going on. And that's where you have to do something wired. But man, we have seen a million projects where people implement their own CAN buses, and you should absolutely do it. It's no more trouble than buying the right interface chip and hooking it up to the microcontroller of your choice.
Pick this last one because I think it's ridiculous, but I wanted to talk about it. Maybe I'm being too negative. Fixing astronomy in the blink of an eye. There's a very real problem. Well, if you're an astronomer, it's a very real problem. Well, light pollution. And, we're getting more and more super bright LEDs in buildings and streets, and that's producing more light. And there's been some research that says, every year visibility drops 10%. You can see, 10% fewer stars in the night sky, even in areas that were once considered dark skies and ideal for observations. It's a tricky problem, right? People like light at night. That's we've got to become accustomed to that. So you can't really say, hey, we have to make all the cities dark again. That's not going to happen. So a company called Stealth Transit, which is great, have a technology called the Dark Sky Protector. If for nothing else, they really have a way with names. It is an idea, and I stress the idea part. What if all the LED lights in a city were controlled and synchronized in such a way that they would flash off at a predictable time, but fast enough that the humans, living amongst the city wouldn't notice? They talk about 150 hertz or something. There would be a dark period, very briefly, that your telescope could then be synchronized to, so that you only make your observations in this fraction of a second dark period where all the city's lights have gone off. This is perhaps one of the more fantastical ideas I've heard in a long time, for a lot of reasons. Just imagine the logistics of getting all the lights in a city to be, ideally yours, right? You want to sell your lights to everyone, every street light, every house, every car, you want to sell the Dark Sky Protector to everybody who has a light. Imagine being able to do that and then synchronizing your telescope with it. Even if you started from scratch, this would be a hell of a thing to pull off. So on a large scale, I think it's just they're looking for investor money, and more power to them if they can get it. Al wrote this one up, and he did kind of make the point that, all right, obviously this is never going to happen on any kind of super useful scale, right? We're not going to be able to darken the East Coast of the United States with this technology for many, many reasons. But if you had lights on campus, right? Like you had a telescope set up on a college campus or something, you could conceivably have all those lights controlled with a similar technology, or at least all the lights, around the telescope, in wherever you're doing your observations. So there might be something here on a hyper local installation, and maybe that'll be the future, right? Maybe it'll evolve to something more grounded. But yeah, the idea of this doing it at like city scale seems crazy, but maybe there is something here for smaller telescopes and I mean I appreciate that they're thinking about the problem, but I think this might be this might be barking up the wrong tree.
Well, my first quick hack, speaking of astronomy, is Palomar puts an observatory in your hands. And then that's a joke on Palomar Observatory by Matt H. This is a Pi for a bunch of 3D printed gears, a Raspberry Pi HQ camera, and all of these together make a tracking long-term exposure portable tabletop observatory telescope. That's just a really sweet build, and he gets some good photos out of it. Up next, Robert Gilding, LiPo replacement keeps portable scanner in the action. If you have old devices that, you can't get their crappy old battery packs for, or you're just tired of dealing with these horrible nickel cadmium nightmares, this is a great tutorial and very simple in how to replace it with a modern lithium polymer battery. And last up, a skewed box, CNC plus microscope plus game controller equals awesome. And that basically summarizes it. This is an automated microscope made up of one of those dirt cheap 3018 style CNC machines, which frankly aren't very good as CNC machines, but as long as they can move a microscope around, you've got a cool remote controlled stage, and combine that with the ability to take photos remotely, you can do some really cool photo stitching together. This one really seems entirely full of possibilities on a kind of not very expensive budget.
All right, for my first hack, I've got a brand new antique radio, and this one is from Craig Lindley. I have always loved that old school, I'm sure there's a term for it that someone will remind me in the comments, but those old school like 20s and 30s radios look kind of like a little church on your table. And I always had kind of this idea of getting one and putting modern electronics in it, but there's a certain uncoolness of taking an old classic piece of gear and putting a Raspberry Pi or whatever into it. This project kind of solves that problem with the most modern of modern technologies, a laser cutter. They cut out the wood and they do like a living hinge to do that kind of curved top, and they cut the little church window things out of the front of it, and it's not going to fool anybody. Obviously, it's not really a 100-year-old radio, but it definitely gets that look across with all modern materials and modern technology. So I think that's a really cool middle ground between, getting the look of something old without having to actually destroy something old. Next up is City Pi Project promises open source movie making. This is a open source hardware and software project that turns the Raspberry Pi and the HQ camera module into a, well, not film, but cinema quality camera. It's really cool in that all the hardware is very modular, very off the shelf, Adafruit, Seed Studio kind of stuff. Nothing crazy. You don't have to have any custom circuit boards made. I mean, the hardest thing would be, printing out the case. And then that's paired with some very slick software to give you this nice touchscreen interface that looks like it could be from a commercial camera to pick the resolutions and the frame rates and all that kind of stuff. It saves the video to like an external SSD, high resolution. It's a really nice setup, very well thought out. And what I thought was particularly cool is that the group that's working on it has already kind of put together like a short film that they use the camera for, not for the whole thing. There was some discussion of that in the comments, but at least some chunk of this movie was filmed with this open source DIY camera, and it looked good to me. It looked certainly better than any film I made. So, if you're a amateur filmmaker and you're looking to get into things and dismayed by what the cost of a proper cinema, whatever camera would cost, then maybe this is a project to look into. And then finally, bringing back the CRT experience and software. If you are of a certain age and remember playing games or even using a computer on a CRT monitor, there's a certain there's something about it. It's the curve of the screen. It's the the little pixelated look. It just doesn't look like modern display technology. And There's an argument to be said that that's better, but some people really still dig the old look, and especially if you're talking about playing an older game, or if you're trying to make it look like something is an older piece of software, you might want to actually recreate that look. So this is a project called Cathode Retro, and it's a collection of shaders and open source code that lets you implement that look in modern software. And it's not something that you're going to do for every program that you write, but if you have a need to recreate that vintage look on a modern display, the end result is very impressive. They got some demo pictures and stuff. It really does look the part. Something to keep in mind if you want to have that old school look, but without the old school hardware.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I want to pick Al Williams's How to Talk to Your Scope. And this is first of two pieces, I think, where he is diving into Visa and SCPI, which I think we're going to call Skippy.
I like it.
And the other different languages that oscilloscopes like to talk these days. He's doing this in particular with a Rigel scope. I've done kind of the same sort of thing with my scope, which is a now very old in the tooth Agilent scope. They surprisingly speak basically all the same language, although kind of different dialects of it. Like where one of them will say, the Rigel says wave data to get the oscilloscope trace. The Atek scope will say curve, and I think mine just says data. But anyway, the commands are different, but they're all basically the same, which is to say they're all text-based commands that you can issue. You get the data back, and then you can process it. And most scopes will let you do this over whatever they've got to plug them in. It's, serial over USB, TCP sockets on mine. I don't know. There's a whole bunch of options there. I guess there's that old school GPIB bus, which is, this is like a horrible, unique interface rather than just a USB or Ethernet cable. So I pity you if you have to deal with GPIB, but in the end, it's just text over serial on this thing as well. And so Al kind of starts off on this one, demystifying it, making a simple library to decode some of the stuff that comes across from the Rigel and, set the trigger, ask it for a sample, all the sort of control-y things you'd like to do with the scope. And it's actually surprisingly useful. Like I said, I've done this with my scope for a couple projects a while back. One of them, I wanted to figure out how far away I could detect lightning strikes using a really simple radio receiver. And that was like the all-band radio from TechLib. I'll throw links in the show notes. It's just basically a couple amplifiers. That was a fun project. I learned a lot, but what I mostly learned was how to control a scope with it and how simple it really is. Anyway, this is the first one in a two-part series. The next one, I think Al's going to make a sweet GUI to go with it.
It takes a special meaning, having worked with Al on the SuperCon badge firmware a little bit and knowing how much he hates Python. I really appreciate that he then turns around and says, well, I guess I'll just stick with it. I'll really lean into it, and I think he even mentions that in the write up. He's like, I just got off doing the MicroPython for the SuperCon badge, and I think he leaves off the part where he hated every moment of it, but he does say like, Python's in my head, so I guess I'll use that for this project. But fun to see what the different writers are working on in their spare time too. So it's cool that he talks about he had already written a similar tool, 8 years ago. Time flies when you're talking to scopes, I guess.
Right.
So he had this nearly a decade old program that he had done, and kind of coming back and dusting things off, and seeing what's out there, what the new hotness is in software controlled oscilloscope. So it's a cool project. I'm eager to see the rest of it. And I will cherish it all the more knowing that Al Williams is cursing under his breath as he writes this code.
And if you haven't played around with this sort of thing before, there's a lot of times where you're just doing some kind of simple experiment and you're like, oh, I have to write down observations at every whatever in like a notebook on paper. What
Feels
am
like
I?
work.
Some kind of caveman? Just write a script to do it. Jeez, it's not that hard. And that's my recommendation. It's really fun to try to coordinate a bunch of measurement equipment. I guess I did just say that, but it really, but it really is, and it really was. And if you have a project that needs it, this is the sort of thing you should do. Dead simple. Here's a good example of how to do it.
What are you doing Saturday night? I'm coordinating my measurement equipment.
Getting my multimeter to talk to my oscilloscope and putting it all into a database.
Yeah,
What are
don't
you
wait up.
doing?
It's gonna be a late night. My pick for this week is Aria's Revive a Sony Vaio P series with KiCad's background bitmaps. Little bit of a mouthful there, but I thought this was a really cool one in KiCad 7, or the KiCad. I forget how we're supposed to say it. I'm going to say KiCad. In KiCad 7, they added a feature, I believe I read about it on Hackaday, actually, where you could, import an image into the PCB editor and then, build your new board on top of it. The idea being you could reverse engineer a board, right? You could draw your traces right over the old traces and that sort of thing. And I got to be honest, I was a little underwhelmed by this when I first heard about it, because I said, well, that seems kind of unnecessary. I mean, why do the traces have to match the existing traces? Reverse engineering a board, the end result seems more important than where the traces are. And, for anything else, I got calipers and I can just measure it and that sort of thing. And I think I was thinking on too small of a scale. And this write-up is actually a great example of why you might want to do that. And why you could, in this case, Aria has this little, I guess you'd call it a sub notebook or something. It's a tiny little, barely bigger than a phone, portable from '09. It seems like it got cooked through some misadventure, the main board shot. So she wants to create a new main board for it. And I guess I was just a lack of imagination on my part where, I couldn't imagine somebody would make a whole new main board for a tiny little computer with this feature, but that's where she's at. And, it starts with taking the old board out and, getting good shots is tricky unless you had like a proper overhead camera lighted rig or something, and more power to you, right, if you have it. But in her case, it was easier to throw it on a flatbed scanner and get a high res image. And she talks a little bit about using GIMP or your photo editing software of choice to like mess around with the perspective and get everything as square as possible, right? Because you really want to be able to line it up with as much precision as you can muster. And then you can bring that into KiCad and you can do your edge cut lines, follow the original board and, put the mounting holes where the mounting holes have to be and put your connectors where the connectors have to be. And, it's something that if it was some little dinky gadget with, one connector on the back and like a little board, you could eyeball it easy enough. But I mean, when you're talking about now a motherboard that has to fit inside of a tiny little portable and all the connectors need to line up with where they're expected to be. And obviously the mounting holes need to be right. And there needs to be a weird little cutout notch because there's some other board sitting next to it that has to fit there. That it's way more complicated than what I had even dared to dream of in the first place. So it's really cool to see how this feature could be used for a very ambitious kind of reverse engineering project. And also what I thought was really cool, she talks about, I'm going to make a new motherboard for this thing. And I was like, God, that's a serious project. Because at first I thought we're talking about actually still using the original CPU and everything. And I was like, wait, that's super ambitious. I my hat's off. But then, actually looking at the board, the idea is to drop a Raspberry Pi Zero into there, which is still, don't get me wrong, it's still going to be very ambitious to put a Pi Zero in there and still have, the screen and the keyboard and everything work as intended. But it's at least a little less crazy than, trying to get the era appropriate CPU and stuff actually socketed into it.
Yeah, I love this idea. And this is something that I use a lot in computer-aided design for making like 3D models to mill out or even print out. It's really super convenient to have a photo of the space that the thing needs to fit in if it has like a weird outline or it has to like mate with some kind of odd organic shaped part, right? And you're
Right.
trying to make a 3D part that works with that. It's super useful if your 3D modeling software can import a picture of the crazy organic thing and then you can kind of model around it. And I see this as a lot that way, except for PCBs, right? Like she's got a photo of what this PCB needs to physically look like. And being able to import that photo in there basically means that you just kind of trace the lines out and you're good to go. At the same time, it shows you where all the connectors need to go, that kind of macro level stuff. But at an even higher level, it kind of lets her plan out where everything's going to be. And I actually really like that. And I wonder if this is going to be something that people will use this feature for in the future. It kind of lets you just sketch out where this functional block should be, where this functional block should be, where this functional block should be. And then when you're laying out the PCB, your job is to then just fill in all of these little blocks, right? Like, it's kind of cool to have this, bigger, even bigger level, one step back overview of the board saying, here's where the zero is going to go. Here's where this converter needs to go. Here's where the power section needs to be. Here's where the EEPROM needs to be. Sure, when you're putting the pieces down, from your schematic capture and then you've got all the pieces on the board, you can just kind of put them all in the right place like that. But this gives you, kind of an even higher level overview of it. And so there's two ways I could see myself using this. One is to make those weird shaped PCBs to mimic an existing board or to fit into a tight or weirdly shaped space. But then the other side is it might even be cool just to make a sketch first of how you want the thing to work and then just kind of populate the board when it comes to doing the PCB layout over that sketch.
I know exactly what you mean. You got the art at the top of the page. It was really cool to kind of see this overlaid thing of what was there before, and now this sort of like I said, block diagram of here's where the power manager will be. Here's where we'll put a USB hub, and you kind of get this idea of a rough sort of placement before the heavy lifting of actually dropping all the parts and running the traces. So I think that could definitely be very helpful. I'm excited to see more people using this now, and maybe now that I've kind of had my eyes open to it. Maybe I'll even find an excuse to use it for myself because it is a very powerful kind of thing for, like you said, there's going to be weirdo boards out there. We've all opened stuff up and just saw like a little square board with, a JST connector on the side and whatever. That kind of thing is no great challenge. But, this board here is an excellent example, especially, I'm looking at like that bottom curve. Like you said, it's almost an organic kind of thing where it's got these like weird waves that presumably something must butt up against it, right? Because you got this tiny little handheld. Your instinct might be, I'll just square that off, but no, because that 2 millimeter little notch is critically important for fitting it in there, right? So
if it's a Sony device, they had it packed in that tight, right?
The method is cool enough, right? And I'm glad we get to see this kind of behind the curtains view of how she's doing it, but I just really like the idea of taking this older handheld that still has, she says that the screen's fine, the keyboard's nice, it's great form factor, but it just, even if it wasn't broken, it's a 2009 processor and all that comes with that, right? So if you could just drop a Pi Zero isn't blowing anybody's doors off, but at least it's a known element, right? And we know what it can do and what software is available for it, and you can run modern stuff on it. So I think it's really cool to be able to do a drop-in board for these interesting machines and do it in a little bit more of I guess I'd almost say a non-destructive way, right? Because we've seen plenty of people gut old stuff and cram a Raspberry Pi in there. I don't want to say inexpertly because it does take a certain amount of skill to do it, but it's a very invasive procedure, right? So I really, really appreciate this idea where, she's making sure like the little flex connector for the display is going to click right in where it's supposed to. Like there's no hot glue required to put this thing together. So I'm really, really excited to see more of this project developed.
That wraps it up for this week's Hackaday podcast. Thanks a ton for listening. If you want to follow along with the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us a line, tips@hackaday.com. And until next week,
keep on making new motherboards for old computers. What is the word for? God, it's early to screw up so bad.
which one does he use here? He's got a newer scope. I don't know.
Well, I might pick. let me choke first. Let me get the choking out of the way.
I think that's a wrap.
Wow.
Painless.
So I have so many positive reviews all over the internet. Hosts Trevor and Adam talk about the week's hacks, and I was like,
no.
which one am I? Which one is Elliot? Is Elliot?
I don't
Trevor?
think I want to be Trevor.
Yeah,
I don't
who's
know,
Trevor?
Yeah,
Am I an Adam? I could be an Adam, maybe. That works.
that's beautiful.
You want to go to the grocery store the day before Thanksgiving, like more of an adventure than I'm looking for right now.